days, more and more underground storage tanks are being removed, or at least permanently closed in place. But unlike days gone by, tank closings now involve a certain amount of regulatory pomp and circumstance, procedure, paperwork, and often, as you will see, an element of danger.
Anytime that you're dealing with a flammable liquid, anytime that you're dealing with vapors that could cause problems, certainly even though that a tank is empty, it still might be volatile. It still might have that capability of explosion.
When it comes to tank closure, every site and situation is different. Most of these tanks store or have stored petroleum or other products that add an explosive dimension to the whole business. Some tanks that have been buried for 10, 20 years seem to want to stay put. Some days an inspector arrives on site and nothing is going right for the contractor. It's hot. They're struggling to get the tank out. Tempers are on edge. You may find yourself walking into a situation that just doesn't seem safe. Sometimes it looks like an accident just waiting to happen.
It was an accident that left 23-year-old David Stubbs of Biddeford dead and at least 3 others with injuries from burns to laceration. It was just after 1 o'clock when an explosion rocked the corner of Cumberland and Washington Streets in Portland's Munjoy Hill. Workers from 2 companies were in the process of removing an underground gasoline tank from a station closed since December.
All I can tell you, sir, what I've told everyone else, there was just some sort of explosion. I was back to the tank. I dove immediately under the pickup truck and out the other side, and then when I turned around, of course, everything was aflame.
Bomb dropped over here, you know. It's a big, huge explosion, a flash of fire, the concussion, the heat, everything just blew over this way. Lucky, I guess, that the station here didn't blow up, too, because we were pumping gas at the time.
Accidents, explosions do happen. In this accident, a man was killed when the end of a tank blew off. There are stories like this all across the country. Because you are dealing with explosive vapors, potential ignition sources, open pits, and other perils, environmental and fire inspectors need to be able to recognize potential dangers, to be able to red flag, even stop a bad situation. In this video, we'll focus on the safety aspects of tank closure for both removal and permanent closure in place. Dealing with these tanks is an important job, and it can be done safely. You'll learn how to recognize and evaluate potential hazards and learn how such hazards can be controlled. In another video, we'll dig into the environmental aspect of closure, the inspector's field evaluation, to see if any contamination cleanup action is necessary. For now, let's look at safety and meet an environmental inspector who has presided over numerous tank yanks.
Okay, where is this facility located? Okay. And what type of product is stored in the tank? I see. Was there a precision test run? I see. And what was the leak rate? Okay. Any inventory problems? Okay. Because of the leak, you must arrange to have that tank emptied immediately. Okay. When is the earliest time we can arrange for the removal? Okay, tomorrow. Very good. I'll be on site tomorrow. Be sure to notify the fire department or code enforcement official.
No matter which state or town you're in, this is the kind of information you need to be aware of before you hit the road to make an inspection.
We want to see as many of the unprotected and unnecessary tanks out of the ground as possible. We inspect sometimes 2 or 3 tank closures a day.
To begin the procedure, the owner or contractor is required to fill out a permanent closure application, which asks a lot of questions about the tank, its age, capacity, material stored, how they plan to handle the tank removal, the disposal, and so on. It's important to discuss the procedure with the contractor over the phone so that he knows what to do before you get there, and he knows what you expect. For environmental agencies, the primary reason for doing this kind of inspection is to look at the tank, the soil, and check for any free product. But in doing that, you never know what you're going to find.
Safe tank removal is the contractor's responsibility, but not all contractors know the score on this subject. So at least if an inspector understands why tank removal is dangerous and what procedures and precautions can make the whole business less dangerous, then he or she is in a position to throw out some helpful safety hints here and there. The biggest danger stems from those flammable and combustible liquids so commonly stored in underground tanks. So let's take a few minutes to discuss flammable and combustible liquids and pick up some tips from an expert on the subject.
Underground storage tanks are extremely dangerous. They're dangerous because of the flammable vapors that are present as a result of the previous product, such as gasoline, that was carried in these tanks. To be safe in working with these tanks, you have to do three things. You have to recognize that there's a hazard, you have to evaluate it or measure that hazard, and then you have to take action to control it, which is to eliminate or minimize that. What you need to be concerned with in terms of what creates a fire hazard is called the fire triangle. It consists of three elements. You need a fuel from the product vapors that are contained in that tank. You need oxygen, which comes from the air, and that supports the combustion. You also need an ignition source. If you don't have all three of these, you will not have combustion. The recognition, evaluation, and control of those three elements are what you need to concentrate on in order to make a safe workplace.
Before anyone begins to deal with the flammable vapors in the tank, the contractor should prepare a safe workplace. Take precautions to eliminate all potential sources of ignition from the area. This includes ignition sources from sparks that fly from banging metal tanks with backhoes or shovels, or from the discharge of static electricity, which is why motorized equipment must be grounded.
While making an inspection, you want to see that the utility lines, gas lines, and water lines have been marked, and that the area has been roped off. You don't want backhoes ripping into the wrong things or pedestrians disappearing into places where tanks used to be.
We shouldn't have a problem with any of these utility lines coming in with this end tank because we believe that it runs parallel with the road away from those lines.
Yeah, we've got a good 6 foot of clearance, so I think we've got a safe location here. The tanks have been vacuumed.
All right, we want to make sure, too, that when we start digging, we pile our spoil towards the street to protect ourselves from any vehicle traffic that might want to come in and get gas.
Okay, I think we're all set.
Once you have a safe workplace, then remove any remaining product in the tank. Drain the product lines at both ends as they become accessible. Here is a fairly typical underground storage tank setup. However, for graphic purposes, the vent pipe is shown closer to the tank than it actually is. Once you've excavated to the top of the tank, remove pipe and pump appurtenances. But leave the vent pipe. The vent pipe should remain connected and free of obstructions until the air in the tank is safely below the flammable range. Once you have a safe workplace and the tank has been emptied, you can begin to deal with getting rid of flammable vapors in the tank before doing any work that could cause sparks and while the tank is still in the ground. This brings us back to the fire triangle.
In order for the contractor to effectively control the fuel side of the fire triangle, he needs to be aware that there is, for every product, a flammability range.
What is this flammability range? It's the mixture of fuel and oxygen necessary to produce a fire or explosion when in the presence of an ignition source. That ignition source could come from a cigarette or the slightest spark or static electric charge. For most petroleum products, the flammable range is between 1 and 10% concentration by volume in air. The flammable range for gasoline, for example, is 1.4 to 7.6%. Below 1.4%, not enough fuel is available to burn. Above 7.6%, the mixture is too rich to burn. Just like a car engine, if the mixture has too little fuel or too much fuel, there'll be no combustion. It's either too lean or too rich. So anyone in the business of handling tanks that have stored any kind of flammable or combustible liquid should know that they need to eliminate or reduce the flammable concentration in the tank before they start handling it. How is this done?
The common practices for eliminating or reducing the flammable concentrations in the tank are purging and inerting.
This is a subject that often seems confusing, but it's really a matter of thinking back to the fire triangle and of understanding whether you are dealing with the fuel or the oxygen side of the triangle, whether you're going to purge or inert the tank. It was quite a while before I ever realized that there was a distinction between inerting and purging, but the distinction is significant.
Purging replaces the flammable vapors in the tank with air. No vapors means no fuel, which means no fire or explosion. Inerting displaces the oxygen and some of the vapors in the tank with an inert or non-reactive gas, such as nitrogen or carbon dioxide. No oxygen means no fire or explosion. Now, what about purging? When a contractor removes vapors by purging, he is ventilating the tank by either blowing air into the tank or sucking air out of the tank. This can be done by blowing the air in through a diffuser so the vapors are stirred up sufficiently to be moved out of the tank. Or by using a device called an adductor, which draws vapors out of the tank and draws fresh air into the tank. Be sure that when these vapors are vented through the adductor, they are discharged at least 12 feet above the tank. In any of these processes, dispersion of the discharged vapors is very important. Vapors must be safely vented up and away from the work area. Since the vapors are heavier than air, contractors should be monitoring the air both at ground level and inside the tank. In fact, there may be days, when it's hot and humid or when the wind is still, when the air simply won't disperse the vapors. So it makes good sense to put off working with the tank until conditions improve.
During purging, it is essential that you frequently monitor the flammable concentration of the flammable vapors in the tank to be sure that your purging operation is effectively lowering the flammable concentration in the tank. To do this, you use a combustible gas indicator.
And I'm not exaggerating when I say the combustible gas indicator, better known as the explosion meter, can be a lifesaver. The explosion meter measures the flammable concentration of the vapors in the atmosphere and gives a reading in terms of the lower explosive limit, commonly referred to as the LEL. The lower explosive limit is related to the lower end of the flammable range we mentioned earlier. During purging, you want to lower the flammable concentration in the tank to less than 20% of the lower explosion limit. In fact, some local codes play it safe and require a concentration of less than 10%.
Explosion meter gives us an element of safety. It's our way of deciding if a tank is safe to be worked with or not. It's our barricade against an explosion.
Okay, there's your basics on purging, getting the vapors out. Now, what about inerting?
The objective of inerting is to lower the oxygen concentration to the level below which there is not sufficient oxygen to support combustion. In normal air, there is 21% oxygen. 11% oxygen is a theoretical limit below which combustion will not occur.
The two most common inerting procedures use dry ice, which is frozen carbon dioxide, or compressed nitrogen. When dry ice is added to the tank, it should be dispersed as much as possible. The dry ice goes through a transformation from a solid to a heavier-than-air gaseous form of CO2. This displaces the oxygen and some of the vapor product. Carbon dioxide is best applied as dry ice, a solid, rather than as compressed gas. The process of introducing bottled CO2 into the tank can create static electrical charges. You know, ignition sources. In other words, it's a lot riskier. Compressed nitrogen is an inert gas that is pumped through an opening in the tank and down toward the bottom so that it mixes and distributes throughout the tank. Inert gases should always be introduced under low pressure to avoid any generation of static electricity. To ensure that the necessary inert gas concentration has been achieved, the contractor should frequently test the tank atmosphere with an oxygen indicator. This instrument measures the amount of oxygen in the tank space. For inerting purposes, it should be calibrated at the lower end of its scale. Common practice is to get the oxygen down to 8% or lower to play it safe. Due to the lack of oxygen, an inert tank should not be entered unless specific safety precautions are followed. Even in the best of circumstances, tank entry is dangerous business. So, that's inerting, replacing oxygen with a non-reactive gas. And the purge replaces the vapor with air. Water can also be used to remove oxygen and vapors. The residual product floats to the top and is pumped off. The water must then be pumped from the tank and disposed of properly. And this can sometimes be a nuisance and not too practical for larger tanks. As you can see, there are a variety of ways to make a tank safe to work with. Which of these methods is best? Now that seems to be a matter of personal preference, convenience, or local tradition. The important thing for you, the inspector, is to be able to recognize potential hazards no matter which method is being used. Also, for any of these methods, in-tank readings for vapors or oxygen should be taken at the bottom, middle, and upper portions of the tank. And instruments should be cleared in clean air after each reading. It's important that contractors understand how and when to use these monitoring instruments. Always keep in mind, any vapor-freeing technique is temporary. The sludge and residues in the tank continue to emit vapors. Never take it for granted that the tank is vapor-free. The rule to remember? Test frequently. This subject may seem complicated. That's why we have a companion booklet to this video that you might want to check out. Anyway, once the tank is safe and you can bring in the heavy equipment, then that vapor-generating sludge needs to be cleaned out. The big sticky wicket in tank removal is the sludge and scale remaining in the tank, the residue that stubbornly hangs in there, lingering on as a source of continuous and dangerous vapor regeneration. A 5,000-gallon tank, for example, may well have 5 to 10 gallons of sludge remaining in it. Ideally, a tank should be cleaned on-site. But this is more or less a risk assessment based on physical surroundings, population in the area, and the weather conditions that day. Of course, it also depends on whether or not the tank will be closed in place. And it also depends on local regulations. You should always check on specific state or local requirements for any of this tank removal business. If the tank is being removed, the contractor has the option of trying to get at the sludge by tilting the tank so it can be rinsed down to one end and pumped out. If the tank is to be closed in place, the contractor may add rinse water to dislodge as much sludge as possible. In either case, they should visually inspect the rinsed tank and again test for vapor or oxygen levels, because sometimes the sludge is really caked on and needs more serious cleaning. The important thing is to get the tank as clean as is safely possible. The contractor should test the tank space prior to entry, continuously ventilate the tank to provide sufficient oxygen, and provide respiratory protection to avoid breathing toxic or noxious fumes. And remember, keep testing. You want your buddy in the tank to come back out in good shape and good spirits. If the tank is to be closed in place after cleaning, the tank should be evenly and completely filled with a solid inert material such as sand or concrete. Plug all openings and disconnect and cap or remove the vent line. Remember, the tank that is properly closed in place should pose no future environmental or safety threat. And again, check on local regulations. So, as far as making a tank safe for handling and cleaning goes, As an inspector, you want to be sure the contractor is familiar with proper purging and inerting procedures, and that he is routinely monitoring for vapors. The bottom line for all of this is, you've got to think safety while making an inspection.
When I make an inspection, I always bring along a hard hat to play it safe, and an explosion meter in case I need to check for dangerous levels of vapors in the air.
Some contractors will tell you how they have never had an accident, and that too many precautions mean time and money. But when you get right down to it, ultimately, the cost could be much greater. As an inspector, you get to know the different contractors. It helps when you're both working toward the same goal, a safe and environmentally sound tank closing. Many contractors are right on top of the situation. They know what to do before I even tell them. Because of the nature of tank removal work, there are other inherent dangers that the inspector should keep in mind. For example, the weakest point of a steel tank is its ends. If there is an explosion, the end is generally the first to blow, so it is best not to linger at the ends while inspecting. Make sure the tank has been securely blocked. Stand at the end of an excavation, not the sides. This way you won't be in the path of the machine's arm swing, and a cave-in is less likely from this point. Why push your luck? And while the tank is being pulled out of the ground, stand out of the way. It's not at all unusual for a cable, chain, or piece of lifting equipment to snap and fly out in any direction.
You can never be too careful as far as safety goes on any of these sites. You've got to protect yourself from the general public as far as vehicle traffic, pedestrian traffic. People are very inquisitive. They want to come over and see what you've got going. Sidewalk superintendents, and they could have a cigarette. They could stand on unstable soil and the hole could cave in.
Once the tank has been exposed and unearthed, you may notice that the tank has leaked. In this case, you've got both an environmental contamination and a safety concern.
Here again, our job is to look. Our job is to snoop. Our job is to do a good inspection to see, to make a determination, did indeed this tank leak? Because if this tank leaks, where did it go? Then we must begin to think of perimeter. How far did it go? Did it enter somebody's basement? Is it in somebody's sump pump? Where did it go?
You've got to look around. Check your notes. Where are the storm drains, sewers, houses? Is there a potential for an explosion? If this situation arises and you're an environmental inspector, call the local fire department. Once an exhumed tank is ready to travel, it should again be tested, appropriately permitted or labeled for transportation, and all the holes should be plugged or capped, except for one 1/8-inch vent hole at the top for pressure relief. Remember, if you've got wind whistling through an inerted tank, you could reintroduce an explosive atmosphere. Most contractors choose to transport only inerted or purged tanks. However, some choose to transport tanks in an enriched or too rich condition to a remote site for further handling and cleaning. This practice has some serious safety considerations, so check out the regulations on this with your local fire department or state transportation authority.
When our contractors come to us, we ask them very, very clearly, what are you going to do with these tanks? And the people that we are working with today have a safe area to take that tank. They understand that that tank could be an explosive device.
In most cases, a tank should not be reused. So I want to know about the disposal plan.
Ideally, the tank should go to a scrapyard where it can be cleaned, if it's not already clean, and it can be cut up safely for recyclable scrap. Of course, in many parts of the country, it's hard to find a place to dispose of these tanks. It's a big problem.
We're in the tank installation and tank removal business, and in doing so, it became a much known problem, and it's great a problem for us. And what do you do with these tanks? Where do you dispose of them? We saw problems being created where they were being dropped in farm fields, and they were creating contamination in creeks and brooks. We we decided that we would approach it from an environmental standpoint and set up a disposal yard that could properly handle the contamination within the tanks and safely handle the cutting of the tanks. A tank comes in, it's unloaded, it's cleaned, the residue from the tank is processed through an underground system. It's taken through a series of pits, tanks, pumps. It's finally taken and put through an air stripper for the final process, then put into a fiberglass 10,000-gallon tank. It's batch tested, and once that it meets the requirements of our discharge permit, it's then discharged through the sewer system to the local treatment plant.
Well, there you have some of the ups and downs of tank closure. You want to do a preliminary history on the tank and the site. Think safety while you're walking around the site. Know when to stop a bad situation. Make sure the contractors know how to handle their vapors safely. Remember, we have covered petroleum products in this video. Chemical tanks may require special handling. Be sure the contractor knows how to handle the product in the tank he is removing. Be familiar with the use and the need for vapor and oxygen monitoring equipment. Know when to call in other experts, and find out how the tanks will be disposed of. Yep, tank closure has its share of potential perils and pitfalls, and no question about it, you've got an important job. Throughout the country, more and more tanks are being removed or closed up. Accidents are happening. Lives have been lost. All it takes is that certain combination of fuel, oxygen, and an ignition source. As an inspector, you don't need to go out and be a hero, but some words of wisdom from you could help make these jobs safer for everybody on the scene, including yourself. Right, Peter?
Right. It's a tough job, but somebody's got to do it.
We've presented a lot of material in this video, and if the subject matter is new to you, you might want to rewind and watch it again. Or you might want to check out other resources such as Tank Closure Without Tears, an Inspector's Safety Guide, a companion booklet to this video. The API's Recommended Practices 1604, Removal and Disposal of Used Underground Petroleum Storage Tanks, API 1631, Interior Lining of Underground Storage Tanks, API 2015, Cleaning Petroleum Storage Tanks, and NIOSH's Criteria for Recommended Standard, Working in Confined Space.